4, or any number of rows, these cannot have the non-zero entry in the column 1. They have to be in the 2, 3, 4, any of the columns. So here we can see in the example that has been depicted that the non-zero entry in the for the row 2 is in the column 2. For the non-zero entry in column 3, we don't have any non-zero entry. But in the row 3, what we have is the non-zero entry is there in the column 4. So that is to in the first column we see the non-zero entry is in the column 1. Then for the row 2, the non-zero entry is in the column 2. That is not below the you can say not in the column 1, below the row 1. So we have to understand that it is like making a diagonal kind of a thing. So a non-zero entry will not have you can say it may have the preceding zeros, but it cannot have a non-zero entry below the below you can say the just below the row 1. So and then the third rule that says is below the first non-zero entry of a row, all entries are 0. That means, so you can say the second rule and the third rule, they have to be satisfied. That means you cannot have a non-zero entry in the column 1 once it has already have a non-zero entry. So here you can see wherever the leading non-zero entry is there, so all the values in that column below that, they are all zeros. So this we say if your matrix satisfies all these three conditions, then we say it is in the row Echelon form. Then we have one more definition that we learned, that is pivot. A pivot is basically the first non-zero entry of a row of a matrix in the row Echelon form. So in the row Echelon form, we said we have the non-zero entries. So the first non-zero entry that is there, that will be called as the pivot in the row Echelon form. Then how do we define that this particular matrix is in the reduced row Echelon form if it is in the row Echelon form? So first thing that we have to see is that the matrix is in the row Echelon form. Then if it is in the row Echelon form, then how do we say, when do we say, we can say that it is also in the reduced row Echelon form. So that means here we say in the reduced row Echelon form, the first condition is that the pivot is equal to 1. Here in the row Echelon form, we were saying that the pivot can be any non-zero entry, right? Then the sixth, you can say the point that in addition to the row Echelon form is each pivot is the only non-zero entry in that column. So remember this, that if you can say the pivot is 1, and in that complete column, see now along with, see when we are talking about the pivots for conversion to the row Echelon form, we were focusing on rows. Now for the sixth rule, we can say we are talking about the column. So in that particular column, that pivot is the only non-zero entry. If all these conditions are satisfied, then we say your matrix, the matrix is in the reduced row Echelon form. So any doubts now? Yes. Yesterday some people had doubts, so I have just repeated that particular thing to make it precisely clear that what is the difference between the row Echelon form and the reduced row Echelon form. So if you have any doubts, you can ask, otherwise I'll proceed further. Any doubts?
No, ma'am.
Okay. So here we can see few examples, like the first row that we see, that they are in the reduced row Echelon form. So here you see, if we move row wise, so the first in the row 1, first entry is 1, then below that it is 0, then in the second row the second entry is 1. So it is in the reduced row Echelon form, because wherever we have a pivot 1, in those two columns you can say there is no other non-zero entry. But in the third one, that is fine, because we are bothered about wherever we have pivot as a non-zero entry, the other there we can't have the other non-zero entries. Similarly, in the other matrices, you can see here we have 1, 17, then 0, 0. So then we have another one where we have all zeros. Now, if we see the next few examples, they are in the row Echelon form, but they are not in the reduced row Echelon form, because they do not have first thing, they do not have pivot as a 1. um, if they have a pivot of 1, then then they are also having the other non-zero entries. See in the third example, if you see 1 0 17 1, 1 is the pivot we have over here, but where in the second row you see in the second row, second column, along with 1 we also have 17, which is another non-zero entry, which is not that means it is not satisfying the rules of the reduced row echelon form. Then and other examples also we can see that these matrices which are given over here, that is 3 by 3 matrix, 2 by 2. So these are all not in the row echelon form. Here.